Health 601. This is our first Learning Glass tutorial, and we're going to have a number of these throughout the semester. So these will all be optional flipped classroom types of recordings that you can view through the Blackboard platform. They're accessible to you as MP4 files, as you will have noticed. And they'll all be about 5 to 10 minutes long around different topics that we will be covering in class. The idea is that this provides you with further examples or a little more depth to some of the content that we cover. The way this works is that I actually draw on this board and it reverses the image and projects the correct image to you. And this is called Learning Glass technology. It was developed here at San Diego State University. I do refer to my notes, and you don't see them, but they're just down here. So if I'm glancing up and down, you'll know why. Okay, I think that's what I wanted to say there. So our first lesson, which will hopefully be a pretty nice easing into the material, is about death or mortality rates. Those are synonyms, and I mention that as a starting point because they're really the ultimate outcome, right? When we think about whether a certain exposure or risk factors matters more than another in terms of your health, it's really about not just being sick or healthy, but whether you live. And so we frequently calculate this type of measure, and we calculate it a number of different ways, and that's what we're going to go through. A couple things to keep in mind is that death information that we get in the health world frequently comes from death certificates or medical records. And of course, the information we have is only as good as what's been written down. Usually what you'll see is one single underlying cause of death, and there, in fact, may be multiple causes of death. You can imagine a scenario where somebody passes away from an infectious disease. They also have an infection in their bloodstream, and that spreads to their body. We call that a form of sepsis, and perhaps they're also diabetic. So when they actually died, maybe the sepsis that really killed them. On the other hand, if they were diabetic for many years, perhaps it was actually the diabetes that was the problem. So that's kind of an aside, but just something to keep in mind beyond the numbers that we will look at in this class. Okay, so what you'll see in front of me are 4 circles, and each of these represents 4 different types of calculations that we examine around death. The first is what we're going to call a crude mortality rate. The second is a proportionate mortality. The third, case fatality rate. And the fourth are cause-specific mortality. And there are others as well. This serves as an introduction, but you start to get the idea after a while. So the other thing I've written here is a sample population and world that we're going to examine, where we have underlying population, actually starting at the bottom, of 200,000 people. Total deaths of 800, diseased individuals of 5,000, and deaths from a particular disease X, 80. Okay, and we'll use those numbers as we go through this. So the most basic death rate is what we call the crude death rate. And that's essentially just a way of calculating the number of people who die out of a total population. And so in our particular calculation, we see we have our underlying population, that's our pie here, of 200,000. And our total deaths just represents a small sliver, right? That's our 800. Write that in here if we like. And so what we can do, right, is just say, well, what's 800 divided by our overall number? And if we did our 800 divided by, I think we'll make it 2 million actually, sorry about that, for the sake of ease. We get a number over another number, and we can actually simplify this down to 4 per 10,000. And as you'll see in the health world, we frequently report our figures as per 10,000 or per 100,000, and we'll talk about that a little bit more later. So we have these 800 people who die, and they account for all the deaths in this particular population in this time period that we're looking at. But you can imagine that we might want to segment out these 800. And so we're going to draw a little dotted line here. And we might want to understand how many of these deaths were due to a particular disease versus another, right? So it's sort of our pie now of deaths. Yeah, this is all very gruesome. So these are all deaths, right? And now we know that there are 800 total deaths, right? And the next thing we might ask is, well, how many of them die from a particular disease? In our case, we have our disease X, and we said, well, there are 80 deaths from disease X. So again, let's try to kind of get a little pie. Here are 80. And so we could say that our proportion mortality from disease X is just our 80 over our total number of deaths, which in this case is our 800. And so that equals 10%, right? So we would say that our proportion mortality gives us, right, what chunk of this pie is due to a particular cause, in this case, disease X. And obviously, there are other causes out there, and so we could figure out those other chunks, those other pieces of the pie as well. So what this does do, right, it tells us the amount of people dead in this community from a particular disease, and we might call this a burden of disease, or from that disease. But what we don't know are how many people are affected by that disease overall. So prevalence is going to tell us that, right? So let's combine the idea of prevalence, I'm sort of moving along here, with these death rates to get what we call a case fatality rate. So case fatality rate now takes the number of people with the disease. Okay, so we're going to say that with the disease, there are a certain number of people who are going to be sick, and there are a certain number of people who are going to die. So again, now, let's just write kind of our denominator here. It's those with disease. Okay. And so in this case, we said that there are 5,000 people with disease. So that's our pie. And we know that 80 of those are going to die, right? So our slice is the same, right? But our underlying denominator is different. We said it's 5,000. And so just as a reminder, just write that back here again. Here it was 800. Okay. So our case fatality rate, right, is 80 out of the 5,000. And this is a little misleading because we write case fatality rate, CFR, but it's really a proportion, right? It's just 80 out of 5,000. Okay. And so we can see that 1.6% of individuals with this disease passed away from the disease. And this gives us a measure, right, of how deadly this particular disease is as well. So in this case, you might argue, well, not so deadly. But obviously, something like Ebola would have a very high case fatality rate. It might be 90% or 80% in the recent outbreaks. Common cold would be very low, probably lower than this, closer to 0. Because hardly anyone dies, even once they're infected. Okay. So if you just look at proportional mortality or at case fatality, you don't necessarily see the whole impact on the community. You see the characteristics of the particular disease, how deadly it is, or the proportion of all deaths. But it doesn't tell you the impact of the disease on the community as a whole. So that calculation is the last one we're going to do now, known as our cause-specific mortality. So in this case, we're going to calculate the burden of disease on the whole population. So our circle, again, is our population. Okay. And if you look at the whole population, we're just going to have a small wedge that's due to that disease. And so in this case, we're interested in the deaths from a particular cause, in this case, our disease X. So same wedge again. Okay. But now we're interested in that underlying population as our denominator, right? So that's our 2 million. Okay. And so what you see is that really this should be a much smaller wedge, actually, right? Because the impact of this particular disease in this population is quite small, right? I'm not going to go ahead and calculate it. Well, actually, I could, right? It's just going to be 4 per 100,000. So very few people are affected by this disease per number of people in this population. So that's how we calculate the various death rates. We can get into other rates like age-specific death rates, but we'll stop there for now.